All right, so this is going to be a dead squid dissection live. And what we're going to do for today, what you can expect, is you will be able to see that this is an upper elementary science meets arts lesson. So there's not going to be a whole lot of detailed explanation of all of the parts of a squid, and there's not going to be a whole lot of detailed explanation of art theory. There's just going to be a basic 30 minutes of external and internal anatomy of a squid. Then we'll do about 30 minutes of an art lesson. Probably won't take that long, and then we can have some questions and answers at the end if somebody would like. And then I've got some interactive challenges set up. So let's talk about some rules for the hour. So rules of the hour, of course, if you're on the chats in any way, then please be respectful of others. There are children watching, some of you adults. Practice kindness in your interactions with others and with me. Share all you can in the comments section. And then keep your microphone turned off until you need it. So if you have something you'd love to add to this, I truly would appreciate it. I certainly am not going to say I'm an expert and the best in any of these fields. So love to hear comments, love to hear suggestions. All right, so then the rules of the challenges. If you want to participate in the challenges, then reply either in the YouTube comments or the Hangout chat. If you can't for whatever reason and you want to email to me, I should put that there. You can email me. My email is burnspn@gmail.com, and I'll just go by the timestamp. So whoever sends it first will be the one that would get their answer to be the first one that's correct. That'll be the winner, and the winners will get their names in the credits. Okay, so before we do any of the challenges, let's have a look at this, and we'll stop sharing this screen, and we're back. So I'm going to take this camera and move it down here. So you can see on my desk right now is a gigantic squid. This happens to be a squid from Argentina, and I got it at a Korean market down the street from our house. And let's see. So one thing you got to think about is everything that's alive, no matter what it is going to, or has been discovered that it does 5 things. It will move, it breathes, it grows, it reproduces, and of course I'm forgetting the 5th one. So we move, grow, breathe, reproduce, and if anybody wants to chime in, I'll remember the last one in a little bit here. So we want to look at this animal. We want to see, how is this animal moving? What is this thing doing to help itself move? And if I was doing this dissection in a classroom, I certainly wouldn't do any of this. I wouldn't cut, I wouldn't tell you the answers. I would just ask the kids or adults if they were doing this too. What is it that you would see that this squid uses to move? And it's kind of tricky, this one. I would hope that they would see that it's not just going to be the tentacles. I'd hope that they'd start to get to realize that inside the squid there is space here that's available for the squid. I'd hope they'd see its fins, and probably they would guess that these fins right here would be used to almost fly it through the water, and maybe they would think that the squid would open and close its tentacles here so that it could move and propel itself that way. But in the end, we'd have to tell them, most likely, unless they've seen some other information on it, that squid suck up water into this giant thing here that's called their mantle. So they suck up all the water in here, and then you ask them to see, can they see this little thing in the back that is called a siphon? So it's a little tiny tube here, and you can see that tube, and what they'll do is they'll suck up the water inside of here, and that water then will shoot out. They'll squish it out with this giant mantle muscle. They squish that out, and they direct it in this siphon like a little jet. So if you're a teacher and you want to talk about Newton's third law, you can talk about action-reaction. You could talk about forces of water pressure. You could talk about how this is all one big muscle. You could describe that this is the calamari piece that kids eat if they ever have, rings or chopped calamari, and get them an idea to try and bring it to who they are, right? See if they can recognize any of the pieces as something that is important in their life. Make it relevant. All right, so in pointing out some of those basic features, kids will immediately say, if you ask, well, what do we see on the outside of this? They might say, oh, look at all the little spots. And you can ask, well, what is that for? Why would they have spots? And what's the difference between the spots that are on this side and the spots that are on this side? So they might tell you that, oh, look, over here on this side, this is darker. So we'll talk about that this is the dorsal side, and that you can talk about coloration for camouflage, that if a predator is looking down on the squid, then it's going to be looking down into the deep dark ocean, and if they have darker spots on the top, then it's less likely that a predator will see the squid. And same thing happens, but from below. On the bottom, or the ventral side, you're going to notice that it's lighter in color, and if a predator was looking up into the lighter colored surface or up towards the air, then they would see lots of sunlight, including a lighter color of the squid, so it's less likely the squid is going to be eaten or seen by its predators. All right. So then we point out some different things. Ask kids maybe count the number of legs or the number of tentacles, and they might notice that there are 8 tentacles that are small and have suction cups all the way along. And you would ask them too, what are some of the things that you see with the suction cups? Now, certain squid, especially a big squid like this, if they touch these suction cups, then they'll notice that they're very hard, and they actually have these little teeth rings that are inside of there. And I don't know if this will focus on it right here, but I have a microscope view of it for you in a second. So there's little teeth rings that are inside each of those suction cups. And that might get kids to remember that, oh yeah, I've seen on sperm whale that they'll have giant sucker marks on them because their main food is the squid, and the squid will fight against it, obviously. And when they do so, they'll put giant sucker marks that scratch on the squid. Okay, so we've got how it moves. And how it breathes, we're going to get to when we get inside of there. How it grows, most of the time when we talk about growth, unless it's something that has a very specific lifestyle, like a frog or a butterfly that goes through a source of goes through metamorphosis, most of the time you just have to tell the kids that this has a form of continuous growth. And there's a name for that that's really complicated, so I don't really go into that ever with students. But the older kids, we do. So we talk about it that it grows from a small, tiny little zooplankton. So it's a little tiny plankton piece that's an animal, and it grows and gets bigger and bigger as it eats, and then it gets to its full adulthood. And then we can talk about how it reproduces. We can talk about the reproduction also from once you get inside, but the squid moms and squid dads, they have like this big giant party where they all get together, and the moms lay out all these eggs all over the place, and then the dads come along and shoot them with the sperm, and then that will fertilize, and the little baby eggs will hatch, and then they'll come out as zooplankton, and then that life cycle starts all over again. All right, so let's have a look at a couple of other features that are on the outside, and then I'll have a look at what's going on inside this. All right, so if the kids want to see how it eats, what you have them do is you ask them about it, and then you can tell them that inside here, right down in the middle, they can see that the squid itself has a mouth in there. And they might say that, oh, look, there's something already in it. There's a fish, or you can ask them, well, what's going on inside of there? And then this is when you ask them to get out their tweezers or a dissecting needle and see if they can't pull out something that's inside the squid's mouth. And so if they do, they can reach inside and they can see that the squid actually has a beak. Now, a lot of kids already know this just because it's pretty prevalent in cartoons and media today. But so there are two parts to the beak, and when you have them pull that out, it's usually pretty amazing for them to see that when the two pieces go together, and have them try and recreate and put it back together so they can see if they can hinge it themselves. It happens to be extra slippery right now. So you can see the two parts that are there. And it looks a lot like it would be a beak that would be on a bird, like a giant hawk or an owl or something like that. And then save that for a little bit, because looking under a microscope at that is a lot of fun. Kids can see up close and they can compare this to something else that we're going to find inside the squid. And also you can compare that to those suction cup things that I showed you, the little sharp edges that have teeth on their suction cups. And when you look at them under the microscope, try and get kids to recognize similarities in some way between those. Okay, so we've got how it moves, how it eats. We talked a little bit about how it reproduces. To see how it breathes, you have to get up inside, and we talked about how it grows as well. So before we get too far inside, I want to see if I can switch over to sharing my screen and get a view of these little dots on the outside of here. These little dots we're going to talk a little bit about later, because these are what are inspiring the art project for today. Those little dots are called chromatophores. So chrome as in coloring, and that's what the squids use for a number of different things, which actually brings me to our first challenge. So let's see what we can do here. I'll share this part of my screen, and we'll go back to this presentation. And so the first challenge is this. First person to find a link to a video of a squid changing colors. I'm looking for a video that shows squids changing colors over and over and over again in a little pattern. Doesn't have to be anything specific, but something that we can all see, and you'll be pretty amazed, I think. All right, now in doing that, I'll stop sharing that, and I think you can go back and see the squid here. So this, if you can see this, I hope you can, this is a picture of, or this is a microscope view of a piece of this squid's skin. So this up close is the chromatophore, and you can see here's one chromatophore here, and they kind of just look like little blobs of paint almost. And you can also see that there are some that are smaller and more faded, and others that are smaller, and some that are much bigger. And this is a good time to ask kids what they see. Just have them draw what they see. It's a good time to ask, what do they think these particular things are? How are they used? How are they made? How are they, what's the process? Is there a physical process to seeing these? How are they working inside of the squid's body? And then also what I like to do too is I like to try and get them to recognize the color of that, because once they have the color of that in their mind, then they might be able to notice that the beak has a similar coloration. And they might also notice when we go in to look at the eye here, that the eye itself has a similar coloration. So that's chromatophores. Then I want to show you another look at the, so here are that's the chromatophore. Let me squeeze this over here. And this is an up-close view of a suction cup. Let me back it up a little bit. So there's an up-close view of a suction cup. And it's a very close view. It's about a 400 times view. And you can see, if we zoom in here a little bit, you can see that these are some of those serrated edges. This is those teeth that I was talking about that are on the insides of the suction cups. Those teeth are the ones that are making the marks, or that are grabbing onto anything that this is going to eat, that this squid wants to eat, and also anything that's trying to eat this squid. All right, so there's the whole suction cup. I think down here, this way, I have just the actual piece of the little ring that's pulled out. And look, there's a couple of really cool sharp teeth right there. You can see that there, it almost looks as though there's a pattern even. And that's something you might ask kids too. Do they see a pattern of any kind within the squid's suction cup teeth? All right, so let me switch back to okay, so we're back with the squid. I'll put my gloves back on. One other thing before we go cutting inside the squid here, I want to have the kids look at the eye. So the eye itself, if they're looking at the eye, they might notice that there's actually a piece of, there's just literally a hole right here in the skin of the head of the squid. And behind it is an entire eyeball. So they can see what looks like for us, it would be a pupil, and you would even see a lens that's in there. They can get a really good view of that when they're looking at a squid like this. And then they might even notice that there's sort of an iridescence or a reflectivity of the eyeball on the back here. And this is where you could try and correlate that to any eyeball that is starting to become an advanced eyeball. And there's a whole series of evolution of the eyeball on Nova, which if you want to go to that website, I'll put some links on the end of this video that show that Nova exploration. So I'm trying to pull this out as gently as I can without cutting it, but you can see kids kind of like this, some of them, but this is where I wanted to show the coloration too. Notice it's the same color as the chromatophores. So I think personally that the squid does a very good job of recycling all of its proteins. So the proteins that are being used to make all the different pieces, including this right here, this eyeball, once you can get that out, then the students can have a look at the lens of the squid's eye under the microscope as well. So the squid's eyeball, what we notice too is we've washed this several times, and we've seen that when you take away all the extra stuff, it actually has lots of layers. So this is made of almost like an onion, where it's layered together in different pieces, which gets pretty cool when kids look at this and they start seeing that everything is almost the same in the squid. Then it sort of is a pretty cool epiphany. So let me switch quickly back to the microscope, and you can see inside the squid's can see the squid's eyeball. All right, so there's the teeth again, and we'll scroll way over here to the other slide, and this is the eyeball of the squid. So it's really simple, and I'm sure it's a terribly complex process to make, but the simplicity of it is that it's just a very clear piece of the hardest thing that a squid makes. So it's the same stuff that makes up our fingernails. This is a form of chitin, and that's not a very good image of it because this microscope is a little too clear and close. It's looking for something that's a little more there we go. Okay, that's a pretty good view. So you can get an idea of the layering over here. If you look on the side, you can see where these layers and these little pieces are built up and built on top of each other. All right. So back to here. Now, we're going to cut this open. We'll have a look at the inside of the squid. And I'm going to do this from the dorsal side. Am I going to do this from the dorsal side? We'll see. A lot of times, what you can ask kids to do is pull out this sort of hard structure that's inside the squid's mantle, but it depends on the squid too, because some of them have different sources of these. So if I just cut straight up the mantle of the squid, I always tell kids to point with their scissors up as best they can. This happens to be really thick, so sometimes you have to help students do this. And then what kids will find is right inside this mantle, they'll see a big piece of cartilage, which has been called the pen of a squid. So the pen of a squid is a large cartilaginous backbone-like structure. So it's used to keep the squid's mantle in a strong shape, and it allows for it in certain ways. Actually, I'm going to guess on this one. I think it allows for more muscles to push against, just like our muscles and bones work together to push against each other. So I think that what happens here is because of this, you get the structure of the mantle stays intact, but then you're also able to use this piece of cartilage as a way to push off a little bit. So if the squid is using its strong muscles, then it needs something to push against sometimes, rather than just totally contract. But I'm going to tell you that is totally a guess, so if anybody wants to correct me on that, I'm okay. I would appreciate it, that is. All right, so all I'm doing now is taking the mantle away from the rest of the insides of the squid and trying to do it as carefully as possible, but it seems to be extra slippery today with these gloves on. Of course it would be. All right, there we go. So you can see inside here, and because the main focus of this is to show how a squid is like any other living thing, that it eats, breathes, moves, grows, and reproduces, then I'm not going to spend a whole lot of time on the total internal organ system of the squid, but I do want to try and show off these big beauties right here. Because one of the things we talked about is that all living things eat, breathe, grow, reproduce, and move. And in this case, this is the way it breathes. So the squid has these two gills, and each gill is actually attached to a heart. So it has 3 hearts within it. So there's a gill on this side, and there's a heart at the top of that gill. And there's a gill on this side, and there's a heart at the top of that gill. And then there's a heart in the center here that will get all the oxygenated blood, and it will push it to the different areas of the squid. So that covers all the things that we talk about with how a squid breathes, or how a squid is a living thing. Now, of course, kids always like to see the ink sac inside of here. And if you get the small squid, like you can buy at a bait shop, then the small squid, the ink sac is just readily available, very easy to see. But with the bigger squid, then you have to kind of flip it over onto the ventral side, which makes sense because the ink sac is going to be close to where the siphon is, because when it pushes out, this thing that looks like a giant fish back here, it pushes out when the squid has to get away fast, it's got to push out all this water, and the ink is going to be pushed through here. So, kids love to do this too, where they'll break open the ink sac and then they'll write, or I've seen kids do mustaches, I've seen kids do write their names on a card and then take that home, all sorts of different things. So that being said, I am going to give you your next challenge while I reset for the drawing piece of this whole thing. We're going to see how chromatophores relate to Georges Seurat. All right, so your next challenge is challenge number 2 is how many species of squid are there estimated to exist? So on this planet, can you find how many species are estimated to exist? And while you're looking for that, I'm going to switch over to the art piece. All right, so we're back with an entirely different thing. I am looking at a drawing. I did a pencil drawing of a squid, and what I want to try and show kids is how somebody pointed this out to me yesterday. Her name is Joanne, and she works with people trying to get art and literature to make a giant difference in their life. So I'm going to give a link to Joanne, or I'll put a link out here on the end for Joanne as well. So color divisionism. This is something that is affecting you right now. By looking at your screen, by looking at this whole thing, you can see that there are, well, you may not see it, but there are pixels on your screen. And the pixels are the same idea as how Georges Seurat was looking at art in his case. And he was talking about taking little tiny dots and meticulously putting those dots in places where you would want to see extra color. So you may have seen pictures like this, or drawings, or images like that, where somebody has done a nice job of putting lots and lots of pictures, or lots and lots of dots in one spot, and those dots will then build together to make everything that that person wants to shade or shadow, or not shade and not shadow. Well, we're going to do something similar to that, something that Georges Seurat probably would not have liked, because this is a shortcut, and I don't think that he was into shortcuts. Sometimes it took him years to make a painting. And I want to try one quick thing here with you. If I can, I'll set up a focus. If you look at your phone under a microscope, then you can see this same idea of pixelation or of color divisionism with your cell phone screen. And I'm looking at my cell phone screen under the microscope right now. So I'll show it to you. So there, you can see this is focused on my little icon for my text messages. So it's actually a yellow, it's a yellow envelope. Sorry, a yellow message thing coming out of a white envelope. And yet here it is, it shows green right there and blue dot and a red sort of square, diamond, however you want to say it. And that's it. I mean, if you change the intensities of these colors, then you're going to get different different views of what you would see on your screen from far, far away. So up close, this is what they look like, but far away, they show the images. And I'll show you my phone from far away here. Show you exactly what we're looking at. So we're just looking at that spot right there. This little piece right here that shows messages. That little thing right there, that was what you were looking at that had all the different dots. So taking that same idea, this is Georgia Seurat's. We've got a picture of a squid. I'm just going to outline that with black. So you can have students outline with black as best they can. And in outlining with black, you're not doing it on anything except for a hard surface. And I know you've all seen the picture that was on the front. You've all seen the picture that was on the front or the promotion for this particular thing. And that was the same idea as this. So I first learned about this when I was teaching in my children's school using a program called Meet the Masters. And if you have any influence in your school, something like that is a good idea, because kids get exposed to art in different ways than their teacher may expose them. So, all right. So here, I've got this outline drawn. Now, the squid looks like you can see a squid, and you can say, yes, that's a squid. And then what I'm going to do is I'm going to get some sandpaper. I've got sandpaper that is 120 grit. I've got sandpaper that is 60 grit. And this is where you can have kids look and compare and see what's the difference between the 60 and the 120. I'm going to start with the 120, and I'll put it right underneath. And I'm going to choose darker colors down here, and just take a purple, take a dark blue, take a light blue, and I'll just start kind of using the side of the crayon. You can see that as I do that, little dots from the sandpaper show up. Whoops, I went over the edge there. So the little dots from the sandpaper show up. And if you want to change those dots a little bit, maybe choose a different color now. So I might choose some purple. I'm going to pick up the paper and move it just a little bit. So when you do that, now it's not going to just color right over the same dots. Now what you're going to get is you're going to get new dots that'll be colored. And you can shade with other colors, and you'll start to see that a picture shows up. So we're looking at the depth of the ocean. Now I'm going to switch a little bit here, and I'll put the 60 grit. This one has bigger bumps, so I'm going to be able to see more of whatever color I'm about to put on. So I put on this lighter blue, and you can see those bigger bumps are showing up. So that's a general idea, and you can teach the kids all about shading. You can teach them to label. So here's a quick trick for labeling. If you want to have them label that this is the fin, you could put this right over here, and then they color over it, color all around it to get the chromatophores on there. Color the ocean down here as well. And when they pull this up, then it still leaves a little bit of space for them to write in the word fin or however they want to write their label. So these are just little sticky notes. You can get those anywhere and put them on there. And that will leave a space blank for them. And I'll share the image with you one more time. That was the final image that I created from here. The difference is I put art with science here and art with science here using Photoshop. And then to put these little words in here, I just lightened up the background a little bit with Photoshop to make it so I could label these pieces over across the top. But the rest of this was done exactly in the way that I showed you here with the Georgia Surratt color divisionism and sandpaper to make sure that you could see. Ooh, I just got a funny message from somebody. This way you can get an idea of exactly how it is set up for kids to be able to very quickly do something in pointillism rather than spending hours and hours and hours making something like this. Okay, let me go back to here. I see I have still about 20 minutes, and I was going to give you one more challenge and then open it up to questions. So in the last challenge, I'd like to know and I'd like to see a source too, if you could. What's the largest squid ever to be found? I guess this "to be found" is a little bit ambiguous. So let's say this: what's the largest squid to have been caught? Let's do it that way. All right, the largest squid to have been caught. All right. And while you do that, I'm going to check and see the questions. I'm going to check and see the questions. I'm looking for questions. I don't see any questions from people, but I see lots of answers to the challenges. So it's good to hear. And I see some kids are getting grossed out, and that happens. You know, this ends up being a really good alternative too for kids who don't like to do squid dissection. They can come right into this, go to a video like this. It doesn't have to be mine, obviously. It could be anybody's. Go to a video that shows dissections so they can at least get an experience of it. I still believe in dissections, though. I still believe that it's important for kids to actually use the scissors to cut through the different pieces to recognize recognize things they can recognize, because there are always, every time that I do this experiment, I always get something new from kids, no matter what. They're fantastic at finding observations that my brain just doesn't see anymore, and correlations as well. And then even doing this, like venturing out and making a live webcast or doing a video like this, I'm meeting people and learning things that I've never known before about art, about science. And if we encourage kids to do these same types of things, create their own webcasts, take a chance. It doesn't have to be an hour. It could be, 5 minutes, whatever it takes. But have them get out there and take some risks. My friend John always talks about liminal space. Have them take a leap of faith and see where it takes them. Support them, guide them in those ways, and they'll surprise us, I'm sure, especially when it comes time for us to just completely pass the torch to them. I know that they'll be ready for it if we give them these opportunities. Um, all right, well, I don't see any questions that are on the feed here. So if anybody has any questions, I would love to see what I can do to help answer questions. Like I said before, I'm not an expert in either of these things, but I do love working with students and working with teachers as well. So I'll check one more time for questions, and if there are none, then I will sign off. And then work on post-production of the video. Said before, I'm not an expert in either of these things, but I do love working with students and working with teachers as well. So I'll check one more time for questions, and if there are none, then I will sign off. And then work on post-production of the video. All right, so Justin asked about the computer setup. It's just a regular old webcam from, I think it's a Logitech 910 webcam. Probably cost $50 when I got it, I'm not sure. And then the other thing is a microscope that was borrowed from a student that I'm working with. His dad bought him a really fancy microscope. So I should give a shout out to Elisha for letting me borrow this. And it comes with software where you can see all the different, you can take pictures, you can measure, and it's really fancy. So I'll put that information up on the video at the end. And it sounds like that's about it. It doesn't look like anybody else has any questions, which I get. And I hope everybody had a great time. I know this was exciting for me, I'll tell you that much. And I'll finish up with different credits and winners of the challenges at the end. I'll finish up with different credits, links for people to see, credits for the winners, and anything else I can think of that would go along with this video. So I thank you all for watching, and I will try and do something else that's fun like this with maybe not just me, but maybe with students as well. All right, thanks for watching.